Somewhere in the universe, a black hole is devouring matter so fast it outshines entire galaxies combined. But how can something invisible become one of the brightest, most violent objects ever observed in existence? Astronomers call it extreme accretion, a feeding frenzy where gravity pulls matter faster than physics seems comfortable allowing. At the center of this mystery lies a monster capable of consuming entire stars, clouds, and even galactic structures. And one particular black hole has shocked scientists by breaking limits once believed impossible to cross. It isn't just feeding, it's consuming at a rate that challenges our understanding of cosmic balance itself. To understand this beast, we must begin with the simple idea of what a black hole actually is. A black hole forms when a massive star collapses under its own gravity, crushing itself into near nothingness. At its center lies a singularity, a point where density becomes infinite and the known laws of physics collapse. Surrounding it is the event horizon, the boundary beyond which nothing, not even light, can escape. Yet paradoxically, the region just outside this darkness can shine brighter than entire galaxies across the universe. This brightness comes from matter heating to millions of degrees as it spirals inward at unimaginable speeds. Friction, compression, and gravity combine to create an inferno unlike anything found elsewhere in the cosmos. But even among black holes, some stand out as extreme, consuming matter at rates that defy expectations. These are known as quasars, the brightest persistent objects ever detected by modern astronomy. One quasar, in particular, has earned a reputation as the hungriest black hole ever discovered. It lies billions of light years away, meaning we see it as it existed when the universe was young. Despite this distance, its brightness is so intense that it still reaches our telescopes with overwhelming clarity. Scientists estimate it consumes a mass equivalent to our sun every single day without slowing down. That means in a single year, it devours hundreds of times the mass of our entire solar system. Such extreme feeding rates push against a theoretical limit known as the Eddington limit. This limit defines how bright a black hole can become before radiation pressure pushes incoming matter away. In theory, exceeding this limit should choke off the black hole's own food supply. But this cosmic monster appears to ignore that rule, continuing to feed at a relentless pace. This raises a dangerous question. Are our models of black hole physics fundamentally incomplete? To answer that, astronomers began studying the environment surrounding these extreme feeding black holes. They discovered vast reservoirs of gas, stretching across entire galaxies, funneling material toward the central abyss. These streams act like cosmic rivers, channeling matter directly into the black hole's gravitational grip. As the gas falls inward, it forms a rotating disk, accelerating faster and heating to extreme temperatures. This disk becomes the engine powering the quasar's incredible brightness and energy output. Yet, the true violence begins when some of this infalling matter doesn't disappear, but is violently ejected back into space. These jets shoot out from the poles at nearly the speed of light, slicing through the surrounding galaxy. They carry enormous energy, enough to heat, disrupt, or even completely reshape entire regions of their host galaxy. In some cases, these jets prevent new stars from forming, effectively shutting down entire stellar nurseries. In others, they compress gas clouds so violently that they trigger bursts of rapid star formation. This paradox reveals a deeper truth. Black holes are not just destroyers, but also unexpected creators.
But the hungriest black holes push this balance to extremes that scientists are still struggling to understand. Their feeding rates are so high that they may temporarily exceed stable physical limits. This phenomenon is known as super-Eddington accretion, and it challenges decades of theoretical predictions. Instead of pushing matter away, radiation may escape in uneven channels, allowing more gas to continue falling inward.
It's like a cosmic loophole where the black hole bends the rules without actually breaking them. But there's another mystery hiding behind this feeding frenzy, something even more unsettling. If a black hole can grow this fast, how did it become so massive in the first place? Some of these giants formed less than 1 billion years after the Big Bang.
That's barely enough time, according to standard models, for them to reach such enormous sizes. This has led scientists to propose new theories about how these black holes were born. One idea suggests they formed from the direct collapse of massive gas clouds, skipping the star phase entirely. Another proposes that early black holes merged rapidly, building mass through violent cosmic collisions.
Each possibility opens new questions about the early universe and the nature of gravity itself. And the hungriest black hole might hold the key to solving this cosmic puzzle. Observations using powerful telescopes have begun to reveal details hidden within its blinding light. Spectroscopy shows the chemical fingerprints of gas swirling into the black hole at incredible speeds.
These measurements confirm that the inflowing matter is both dense and highly energetic. But they also reveal something unexpected. The gas is moving in chaotic, turbulent patterns. This turbulence may help explain how so much material continues falling inward despite intense radiation pressure. Instead of a smooth disk, the accretion flow may be clumpy, uneven, and constantly shifting.
These clumps can shield each other, allowing pockets of matter to slip past the outward push of radiation. It's a chaotic feeding system, far more complex than the simple models once imagined. And this complexity may be the secret behind the black hole's extreme appetite. But as it feeds, the black hole doesn't just grow. It transforms its entire galaxy in the process.
The energy released from this feeding can push vast amounts of gas away from the galactic center.
These outflows act like cosmic winds, powerful enough to sweep entire regions clean of star-forming material. Without gas, new stars cannot form, slowly starving the galaxy of future generations of light. Over time, this process can transform a vibrant galaxy into a quiet, aging system of dying stars.
This phenomenon is known as feedback, and it plays a critical role in shaping the universe we see today. Yet, in extreme cases, like the hungriest black hole, this feedback becomes overwhelmingly destructive. The galaxy begins to lose its ability to sustain life cycles of star birth and death, and the black hole continues feeding, growing even larger as its host galaxy weakens around it.
This creates a terrifying imbalance where the central monster dominates everything within reach. But even this dominance cannot last forever, because eventually the food supply begins to run out. As the surrounding gas is depleted, the black hole's brightness begins to fade. The once blinding quasar dims into a quieter, less active phase. What remains is a supermassive black hole, still powerful, but no longer consuming at extreme rates. This quiet phase can last for millions or even billions of years. But the scars of its feeding frenzy remain imprinted across the galaxy forever. Astronomers can read these scars like a history book written in light and motion. Each distorted structure tells a story of past violence and unimaginable energy. And through these clues, we begin to understand how black holes shape cosmic evolution. But one question still lingers. and it may be the most unsettling of all. Could our own galaxy once have hosted a similar feeding monster in its distant past?
At the center of the Milky Way lies Sagittarius A star, a relatively quiet supermassive black hole today. But evidence suggests it may have been far more active millions of years ago. Gigantic structures called the Fermi bubbles extend above and below our galaxy's center. These enormous structures may be the remnants of a past feeding event.
If true, it means even our galaxy has experienced moments of extreme cosmic violence. And it suggests that such events may be more common than we once believed. The universe may be filled with hidden giants, feeding in silence or waiting for their next outburst, each one capable of reshaping galaxies, altering the course of cosmic history itself.
The hungriest black hole is not just an anomaly, but a glimpse into the extremes of nature. It reveals how far the universe can push the boundaries of physics and still remain coherent. It forces us to confront a universe where the most destructive forces are also the engines of creation. And it reminds us that even in chaos, there exists a hidden structure guiding the evolution of everything.
From a distance, it looks like a point of light, but up close, it is a storm beyond imagination. A storm that bends space-time, reshapes galaxies, and challenges the limits of human understanding itself. And yet, despite everything we've discovered, we are only beginning to understand its true nature.
Because with every answer, this black hole leaves behind even deeper, more unsettling questions. Questions about gravity, time, and the ultimate fate of matter falling into the abyss. Questions that may one day redefine our understanding of the universe itself. Until then, the hungriest black hole continues feeding, silently shaping the cosmos from billions of light years away. And somewhere out there, an even hungrier one may already be waiting to be discovered.